Okay, good morning everyone, and I'm here in front of you to tackle about my report in factors affecting microbial growth in food. Intrinsic factors. These are inherent in the food. They include pH, water activity, oxidation reduction potential, nutrients content, antimicrobial contents, biological structure. And the second one is the intrinsic factors. Are factors external to the food that affect microbial growth. Hydrogen ion concentration or pH. Most bacteria grow best at neutral or weakly alkaline pH, usually between 6.8 and 7.5. Some bacteria can grow within a narrow pH range of 4.5 and 9.0. Example, Salmonella. Other microorganisms, especially yeast and molds, and some bacteria grow within a wide pH range. Example, molds grow between 1.5 to 11.0, while yeast grow between 1.5 and 8.5. pH values of some food product. Okay, we have food type: beef, chicken, milk, cheese, fish, oyster, fruits, vegetable. Range of pH values of beef: 5.1 to 6.2. Then range of pH value of chicken is 6.2 to 6.4, while the range of pH value of milk is 6.3 to 6.8. Then the cheese 4.9 to 5.9. Fish 6.6 to 6.8. Oysters 4.8 to 6.3. Fruits lower less than 4.5, most is less than 3.5. Vegetables 3.0 to 6.1. These are the pH value of some food products. Microorganisms that are able to grow in acid environment are called acidophilic microorganism. These microorganisms are able to grow at pH of around 2.0. Yeast and molds grow under acidic conditions. Other microorganisms such as Vibrio cholerae are sensitive to acids and prefer alkaline conditions. Most bacteria are killed in strong acid or strong alkaline environment, except mycobacteria. Minimum and maximum pH for growth of some specific microorganisms. Escherichia coli, Salmonella intrica, Cerovar typhi, Alibacteria, molds. Yes, the Escherichia coli minimum is 4.4 and the maximum of 9.0. Salmonella enterica 4.5 to 8.8. Alibacteria 4.0 to 9.0. Molds 1.5 to 11.0. Yes, 1.5 to 8.5. Moisture content. The effect of moisture is in terms of water activity, the amount of free water in food medium. The amount of free water is important for growth of microorganism. If there is lack of free water, microorganism will not grow. Water activity is defined as the vapor pressure of food substance to that of water at the same temperature. Moisture content. The water activity of pure water is equal to 1.0. Food products have a water activity of less than 1.0. A saturated salt solution has a water activity of 0.75. Salting and drying reduces the water activity of food product. Water activity of some food product. Food product, raw meat and milk, their water activity is 0.99 to 1.0. Luncheon meat, his water activity is 0.95. Boiled ham, sliced bacon, water activity 0.90. Then dried grains, water activity 0.80. Water activity levels. Growth of microorganism is greatly affected by level of water activity. In the food, inhibition of growth occurs if the water activity for food is lowered beyond an organism minimum level of water activity that is necessary for growth. Microorganisms have varying minimum water activity requirements that support their growth in food. Minimum water activity that supports growth of some microorganisms. Microorganism Clostridium botulinum, water activity 0.95. Bacillus cereus 0.95. Pseudomonas aeruginosa 0.95. Salmonella spp 0.95. Then Staphylococcus aureus anaerobic 0.90. Candida spp Saccharomyces. Staphylococcus aureus aerobic 0.86. Penicillium spp 0.82. Most foliage, yes, 0.88. Most spoiled molds 0.80. Then osmotic, yes, his water activity is 0.70. Nutrient content of food. Microorganism requires proteins, carbohydrates, lipids, water, energy, nitrogen, sulfur, phosphorus, vitamins, and minerals for growth. Various food have specific nutrients that help in microbial growth. Food such as milk, meat, and eggs contains a number of nutrients that are required by microorganisms. These foods are hence susceptible to microbial spoilage. Antimicrobial substances. Antimicrobial substances in food inhibit microbial growth. Various food have inherent antimicrobial substances that inhibit microbial attack. Such inhibitors are like lactinin and anti-coliform factors in milk and lysozyme in eggs. Biological structures. Some foods have biological structures that prevent microbial entry. For example, meat has fascia, skin, and other membranes that prevent microbial entry. Eggs have shells and inner membranes that prevent yolk and egg white from infection. Extrinsic factors are factors external to the food that affect microbial growth. They include: number one is temperature of storage. Then second one is presence of concentration of gases in the environment. Then relative humidity of food storage environment. The growth of microorganisms is affected by the environmental temperatures. Various microorganisms are able to grow at certain temperature and not others. Bacteria can therefore be divided into the following groups depending upon their optimum temperature of growth. Psychrophilic microorganism. These grow best at about 20 degrees Celsius but also down to 10 degrees Celsius in frozen media. Psychrophilic bacteria can cause food spoilage at low temperatures. Several of the microorganisms found in the soil and water belongs to this group. Mesophilic bacteria. These organisms grow between 25 degrees Celsius and 40 degrees Celsius with an optimum growth temperature close to 37 degrees Celsius. Some such as Pseudomonas aeruginosa may grow at even lower temperatures between 5 to 43 degrees Celsius. None of the mesophilic bacteria are able to grow below 5 degrees Celsius or above 45 degrees Celsius. Most pathogenic bacteria belong to this group. Thermophilic bacteria. These grow with temperature are between 50 degrees Celsius to 70 degrees Celsius. Growth of some bacteria occur at 80 degrees Celsius. Bacteria in this group are mainly spores formers and are of importance in the food industry, especially in processed food. Note that the effect of temperature on microbial growth also depends upon the other environmental conditions such as growth factors in the nutrients medium, pH of the food, and water activity. Concentration of gases in the environment. This relates to the presence of concentration of gases in the food environment. Various microorganisms require for food either high oxygen tensions, aerobic, low oxygen tension, microaerobic, or absence of oxygen, anaerobic. Some microorganisms may grow either in high oxygen tension or in absence of oxygen, facultative anaerobics. Food affected by various groups, anaerobic or facultatively anaerobic spore formers, are most likely to grow in canned foods. Microbial bacteria are most likely to grow in vacuum-packed food since they have low oxygen tension, while aerobic bacteria are likely to grow off surface of raw meat. Aerobic molds will grow in insufficient dried or salted product. Relative humidity. This is the amount of moisture in the atmosphere or food environment. Food with low water activity placed at high humidity environment take up water increases their water activity and get spoiled easily. For example, dry grains stored in an environment with high humidity will take up water and undergo mold spoilage. Okay, so that's all of my report about the factors affecting microbial growth in food or meat, and that's all, and thank you.